And so it's pretty consistent. The wiring's pretty consistent across our line. And so it's a little bit easier to troubleshoot and also to keep parts on your truck. This newer lockout board that we have here on the left, in that left picture, it will actually work backwards compatible to an older style lockout board. We've got a lockout board that looks almost identical to this one here in the picture, except some of the jumpers are different. And on the newer board on the very bottom, you can see there's some 4 little white boxes where we're looking at some thermistors and things. And we'll cover those as we go along, but the older board did not have those. But this newer board, if you were just to keep this newer board on your truck, we could put it on an older unit and get it to work. So it's backwards compatible. The board's pretty cheap. I would say it's probably somewhere around 40 bucks. So it's relatively inexpensive, you know, unlike some of our older double stack boards, you know, where they've had, you know, the ECM board and the lockout board all tied into one, where it might be $400 or $500. Our lockout boards are pretty cheap. And to be honest, they're pretty reliable too. So we don't have a lot of lockout board failures. I'm not saying they don't fail, but we don't have a whole bunch of them that fail often. So that's a pretty good lockout board. So basically, if you have a 2-stage unit, well, it could be a single stage too, it doesn't really matter, but with no fan in the unit, so it'd be like a water-to-water unit, then that's only going to have a lockout board. That also include the split units. Any units that have an ECM fan would have a lockout board and an ECM fan. Then we have the combination unit, which is a water-to-water and a forced air unit, and so that would have all 3 boards. But so all of our units will have a lockout board in them, and then depending on the other functions of the unit, we would either have an ECM board and a combo board as well. So the lockout boards, you can see this picture here on the right, the lighter green board. This is the older style board. You can see it looks very similar to the one on the left, which is our newer lockout board, except for the one on the left has those small white Molex connector plugs on the bottom, where the one on the right does not. There are some test jumpers on both boards. You can see them a little bit better on the one on the right, where you've got that relay that says M516-HP. Right to the right of that, there's a couple little black rectangles, and you can kind of see next to them, one of them says test, one says O/V, and the top one says WSD. Those are jumpers you can remove and get it to operate a certain way. Now, the newer board, I show this picture on the left, there are some jumper pins there as well, and they're really hard to see in this picture. But we've kind of gone away from that as well. We do have a box now that's either red or blue, so it'll kind of stand out a little bit better, and then you can adjust those settings. And we'll cover those jumpers or dip switches here as we go along with this unit. So when we went to the newer board, we've added freeze protection for the source heat exchanger, freeze protection for the load heat exchanger, a hot gas discharge temperature sensor, and a leading domestic hot water temperature sensor. We've also added a jumper or a dip switch, depending on the revision of that board. So you can choose whether you're going to monitor a flow switch or a sensor. And we'll get into that, what that really means here in just a minute. So again, some additional jumpers have been added. It is backwards compatible to our older units. And we do have the little Molex connectors. You can see on the right, you can actually see that red dip switch box instead of those jumpers. So it kind of stands out a little bit better. So, and then you can see the 4 sensor boxes on the bottom of the board. And we've just got some improved logic on the board as well. There are 5 diagnostic LEDs on this unit. And the lights, they're LED lights, so they're kind of hard to see on here, but they're those little white rectangles next to the terminal or the spade connectors on the very far right side, like where it says HP1, you can see a little white box there. That's a light. So you've got one at LP1, HP1, FS, and CO. Now, one thing I want to mention, that those lights are on, that doesn't necessarily mean, let's say the light right next to the low pressure is on. More than likely that means a low pressure, but it could also mean something else. You could have numerous lights on at the same time, one on, one flashing, and it'll tell you a code. We have up to 20 codes on this board to tell you what's going on with the unit. Now, there's only 5 lights, so that means that there could be multiple lights and multiple codes. So you kind of got to have the manual or it's on the unit as well. There's a troubleshooting box that'll say, if you've got an orange light that's flashing and a yellow light that's solid, that means, let's just say, condensate overflow. It'll kind of tell you what that is. So there is a test mode. If you put it in test mode, it'll speed up your time delays. There's fault retry. So if it faults out, it'll shut down, wait 5 minutes, and restart and try to get the unit to run again. It has fault memory to a certain extent. If we remove power, high voltage power to the unit, then we erase the codes off the board. There's no battery on this board to store the codes. So a power interruption would delete the code in there. We do have under over voltage protection and a 5-minute anti-short cycle timer in between on-off cycles. So a little bit of the sequence of the operation on the board itself. So we're in heating and cooling first stage. You're going to have, if you're in cooling, you're going to have an O. And if you're in heating, you're going to have a Y1, a G call, and that'll be your first stage of your compressor. Once it realizes that you have that Y1 call, the ECM is going to start at 75% of first stage CFM levels. Then about 1 to 10 seconds after that call has come in through the lockout board and your ASC or your anti-short cycle timer has expired, the compressor, your loop, and your de-superheater pumps are going to start. After that, the ECM will adjust to 100% of first stage CFM levels about 30 seconds after the call. Now, you may not be able to tell that it's gone from 75 to 50% or to 75 to 100%. You may not be able to hear that, but you should be able to count it on your ECM board, and it'll tell you the CFM. Obviously, O will be energized in cooling mode. In second stage, once it sees that Y2 call, it will immediately adjust its CFM level to second stage, and then your compressor solenoid will be energized as well. When we get a backup heating call, anytime we have a W call, the ECM will ramp up to 110% output to give you a little bit of extra airflow for the electric heaters. Emergency heat call will just be a W call, and again, that's 110% of second stage or Y2 CFM levels. A fan only call would be 50% of Y2. So, if you got 1200 on your Y2, you'd have 600 CFM in your G call. So we have fault retry on this unit. So if you have a high pressure lockout, the unit will shut down and it'll wait for 5 minutes and it'll try to restart. If that high pressure lockout happens 3 times, the unit will then go into what we call a hard lockout. The hard lockout will send a signal to the thermostat that says call for service, and then the unit will shut down and it will not try to restart. Now it's got to be the same fault all 3 times. If you have 2 high pressure faults and then the third is a low pressure fault and then it runs fine, the unit will just keep running. it has to be the same 3 times, 3 high pressures, 3 low pressures, what have you. And again, there is a 5-minute delay in between each retry. So on these newer lockout boards, there's a little bit of sequence that's changed, some logic. One of the things that has changed is that on this newer board, if the low or high pressure switch are open when the Y call comes into the board, the unit will not try to start. So we obviously don't want to run it in a high pressure situation, and we don't want to run it without refrigerant in it. So if either of those switches are open when the call is received, the unit will immediately go into a lockout. It'll wait 5 minutes, it'll try again. If that switch is still open, it'll lock it out. After that 3rd time, it'll go into a hard lockout. I will make a quick note. If you have the unit in test mode and the low or high pressure switch is open, the soft lockout, your first 2 lockouts are considered the soft lockout. Those will happen so fast in test mode, you won't even see it happen, and it'll almost immediately go into a hard lockout where it have to be reset. Because the anti-short cycle is not there, so it'll just see that switch is open, and it'll go into a hard lockout. So the low pressure switch is a setting of, it will open at 50 and it'll reset itself at 65 psi. The high pressure switch will open at 610 and it will reset itself at 420 psi. As long as the low pressure switch is closed when the Y1 call is received, it will wait 90 seconds before it reads it again. So it basically allows the compressor and your pumps to kind of get up to speed before it kind of monitors the low pressure switch again. So then the lockout, excuse me, the low pressure lockout, it has to be open for 30 seconds before it actually faults it out. So as long as it was closed when the Y1 was received, it could be up to 120 seconds before it locks it out on low pressure when it's running. So it can take a little bit of time before it locks it out as long as it was closed on startup. The high pressure switch, again, if it's open when the Y call comes in, it won't start the unit. And anytime that switch opens, it immediately shuts down the compressor. We don't want the compressor to run for 30 seconds if it's at 600 psi or 610 psi. So we'll immediately shut down the system anytime that switch opens up. A freeze or a flow lockout, that's going to depend on a couple things, how you have your board set up, whether it's looking at a thermistor or a flow switch. So we'll come back to that here in just a minute. On startup though, it will not monitor the freeze or the flow input for 30 seconds. Again, it's allowing your pumps to come up to speed and get up to full throttle before it monitors that. After 30 seconds, the flow switch or the thermistor will be has to be open or sensing a wrong temperature or a temperature outside of its range for 30 seconds. So it could be 60 seconds before the unit locks out on a freeze or a flow lockout. The condensate overflow, they're the 2 terminals here, and there's no bypass on startup, and it has to be open for 30 seconds. On the condensate overflow, on the older style units, an XT or a CT packaged unit, the sensor for the drain can go either on the left side or the right side. We prefer that wherever you pipe in your drain, whether that's left or right, that you would move that sensor to the other side, and it'll sense better. You may get a premature fault if you leave it on the other side of it, it's not going to be the end of the world. The unit will still run. It's just going to be when you get a little bit higher water in that pan that you can get a fault. So we try to get that switched over. On the newer packaged unit, the YT unit, the sensor is in the middle of the drain pan, so we don't have to worry about that. If you forget to switch it around on an older unit, again, it's not the end of the world. But basically, there's two wires that run from this lockout board. There's a purple, I think a brown wire or something. And so basically, the water completes the circuit and sends basically a signal to ground, which in turn locks the unit out. If you ever have a condensate overflow lockout and there's no water in the pan, make sure you have a trap on the unit, because our units won't drain properly without a trap. And let me paraphrase that with, the trap has to have fluid in it. So if it's ran all winter and dried out that trap, and then in the summer it plugs up, you got to have water in there, or it won't drain until the fan shuts off. It's the negative pressure coil, and it'll pull air through that drain. So make sure we have a trap on there. And a lot of times I've seen on these little wires that plug in on the spade connectors that at some point the pan has had water in it, and those connectors get a little bit of corrosion on them. So you can take those connectors off and brush them up with a wire brush and put them back on. That seems to take care of the nuisance condensate overflow lockout. If you still have a condensate overflow lockout, you can remove one of the wires here on the board, and then the circuit cannot be completed. So it shouldn't lock out ever on condensate overflow. If you pull it off, pull one of these wires off the board, and it still locks out on condensate overflow, then we know we've got a problem with the board itself. Highly unlikely, but it's an easy way to check whether it's a wire issue or a board problem. Just take one of the wires off, and it shouldn't ever be able to lock out. Basically, the water here just completes that circuit of the actually it's a purple and a green / black stripe wire, the other wire. We do have an under-over voltage lockout. Now, the under-over voltage, it's looking at the secondary voltage on the transformer, so your lower voltage, your 24 volts. It's monitoring that. Now, it won't lock the unit out unless it happens for 15 minutes. Then it will go into a hard lockout. If you ever walk up to a unit and the lockout board has all the lights flashing in unison, that's an under-over voltage lockout. If it happens and it comes back and the voltage comes back within range before the 15 minutes, it'll reset itself. It'll only go into a hard lockout and have to be reset by itself or manually after the 15 minutes. So the over voltage that it's looking at is 31 volts, which is roughly 258 volts on the primary side of the transformer. We get higher voltages than that, and we could get a higher voltage output. Now, you also want to make sure that you have the voltage hooked to the right tap on the transformer. Our transformers are wired for the 240 volts from the factory. If you have 208 volts at the home, then you need to change the tap on the transformer, because that's going to affect the secondary voltage coming out of the transformer. The 29 volts, it will self-reset. The under voltage is 18 volts, which is roughly 190 volts coming in on the primary side. And then 20 volts will reset the board itself. There is an under-over voltage jumper or dip switch, depending on what board you have. If we were to remove that jumper or flip that dip switch to off, it's labeled O/V. It should be OU, but the Europeans like to use V for U. So OV is what it's going to look like on the board, and that stands for over or under voltage. If you have a real problem with your under over voltage light going off, then give us a call and tech support. There's been a few times when we have to not monitor that. It usually happens in a very rural situation where their power is not real stable. And so we may have to not monitor that. If you think that that's a possibility, just give us a call and tech support and we'll discuss it, check a few things real quick, and then we'll make a note that we told you to do that. That way, if something were to happen down the line with the board, that you're covered on your warranty status. One thing that's important with these lockout boards is to understand what the homeowner should do when they do get a lockout. Most of these thermostats now, especially these Wi-Fi thermostats and such, they have the L circuit on the board, which is the lockout circuit. And we have it on our unit to where it'll send a signal to the thermostat to let it know that it's locked out. Now, it's important for the homeowner to understand what they should do when that call for service or check system or whatever it says on there, what they should actually do. Now, should they, turn off the power to the unit? Should they reset it at the thermostat? What happens during a lockout? So basically, if we go to the breaker or to the disconnect or whatever you have, the high voltage to the unit, and we remove it, the lockout is erased from the unit. We don't have that battery backup. So if you want to know what that lockout is when you get out there, the best way for the homeowner is not to go to the breaker and shut it off there and turn it back on. Basically, the homeowner can go to the thermostat, they can turn it to the off position, and they can wait 30 seconds to a minute. Wait for that. They can put it back into heating or cooling, whatever they were in, and it will hold the code on the lockout board of the last fault. It'll also allow it to try to recycle itself 3 more times. And then if there's still a problem, it's still locking out, then it'll say call for service again on the thermostat. Now, I wouldn't have the homeowner keep resetting it at the thermostat. Maybe one time, if it still locks out, then they need to call somebody out to look at it. It could be that they reset it and it takes off fine. And if it takes off fine and then you come out the next day and there's no lockout on there, it's hard to troubleshoot. So if they reset it at the thermostat, it holds that code. When you get out there, it'll still be there for you. So if they reset the unit and it runs fine, those are always the hardest problems to try to diagnose when it works fine when you're out there. It happens to me all the time. I get called out to these site visits. They've reset it. I get out there, it's running fine. I check everything. There's not much I can do. So I just basically tell them, hey, next time it does it, just turn it off of the thermostat, wait 30 seconds to a minute, turn it back on, and we'll go from there. Again, don't have them reset it more than a couple times because there is a possibility that you could freeze up a brace plate or a heat exchanger, if you don't have proper water flow or something like that. And we don't want to burst the heat exchangers. So don't tell them to keep resetting it. Just have them do it one time or so and see what happens. So here I've shown this board here with the red box in the middle. We have 4 dip switches. We have FSW, FZR, test, and O/U or O/V, depending. So test, in test mode, if we put that to the on mode, which is how it comes from the factory, the board will work normally with your 5-minute anti-short cycle. If we flip that to the off position, your anti-short cycle will speed up to just a few seconds, and your status light that's in the bottom right corner of the lockout board will go out to let you know that you're in test mode. So you can test the unit and not have to worry about time delays. Now, if you forget, if you walk off the job and you get home that evening and you say, well, I think I forgot to flip that test jumper back to the normal position, you're like, man, I'm gonna have to go back out there and do that. Don't really worry about it too much. After an hour, the board will realize that you forgot to do that, and it'll revert back to its normal time delays. Now, your status light will still stay out, but it won't affect the unit. You may make a note, to yourself or on your ticket that, hey, I forgot to move that test jumper next time we're out there for service, to make sure to flip that back to the normal position. But it won't affect the unit. So at least after that hour that it's been off. So don't really stress too much about it. We used to have a little jumper and people would pull it off and forget it or lose it. And so that's why we kind of did that. And we've just carried it over to the newer upgraded board. Again, under over voltage, if you flip that dip switch, it will not be monitored. And if that is an issue, just call us. I mean, we'll tell you yes. I mean, I think we've only had to do it a few times, but we just like to know about it because we want to check a few things before you do. They're not real difficult to check, and we're not trying to question your abilities. We just want to make sure that that's the real issue, and then we'll switch it over. We'll make a note in the computer. That way, if something happens, it covers you. So, not a big deal, but just please let us know. Now, we have an FSW dip switch, which is a very top one, number one, and it will come in the on position from the factory. When it's in the on position, we're monitoring one of these bottom thermistors. We have 4 thermistors. If you look really close at this picture, you'll see LCT, DGT, DLWT, and SCT. LCT is load coil temperature. DGT is discharge gas temperature. DLWT is the domestic water line temperature. And SCT is source coax temperature. So on dip switch number 1, if you get this unit from the factory and you have sensors plugged into these 4 on the bottom, then FSW, that first dip switch, will be in the on position, and we're going to be monitoring the T4 sensor, which is the one that's circled. That's your source coax temperature. On the newer units, we're not monitoring a flow switch. We're monitoring water temperature or thermistor temperature. It's not even water temperature, it's refrigerant temperature at the source heat exchanger. So what makes this board backwards compatible, if we were to flip this switch to the off position, now we would be monitoring the spade connector terminals on the right side of this board where it says FS1 and FS2. Now, if you get the unit and you have a sensor plugged into that circled T4, then you will have nothing plugged in to the FS1 and FS2 terminals on the right side of that board. So if you look at the board and say, well, it's going out on flow fault based on the lights, well, no wonder I don't have anything plugged into FS1 and FS2. Now you've probably got something plugged in to this T4 sensor. So we're monitoring sensor temperature and not a flow switch. That's what makes this unit, this board, backwards compatible. If the older units have a flow switch with the spade connector terminals. So if we flip this dip switch to off and plug in our flow switch to FS1 and FS2, now we're backwards compatible to that older board that does not have a T4 sensor. Now, if you want to put this board on an older unit that has a flow switch and you want the sensors, we can send you the sensors and this board, and we can tell you where we want those sensors put, and we can do that. But if you don't want to go through that trouble, then the board that you will get will be this board, and you'll have to flip that dip switch to monitor the flow switch and not the T4 sensor. So again, with a dip switch in the off position, now we're monitoring those terminal connections. So we're looking at a paddle switch that's in the water line right near the source heat exchanger. A freeze jumper, so that is the FRZ. The factory default, the switch is in the on position. When the dip switch is in the on position, that thermistor is looking at 30-degree freeze protection. So an open loop or a closed loop with no antifreeze in it. So we're saying, hey, at 30 degrees, that's going to freeze, so we're going to lock it out. Obviously, we don't want water to freeze. It breaks things. So with that dip switch in the off position, now we're saying, okay, we have a closed loop and we have antifreeze in the system. So we normally have antifreeze protection down to 15 degrees. So that now that that switch is in the off position, that sensor is now looking at 15-degree freeze protection. A lot of times we see this fault on a new install in the winter where the installer forgets to switch that over and they have antifreeze in the system and it gets below 30 degrees, it'll lock the unit out. It's not because it's frozen. The installer just forgot to look at the different temperature sensor ranges depending on the dip switch. So in the on position, that's for an open loop or something with no antifreeze in it. Anytime you're using antifreeze, put it in the off position so it monitors a 15-degree sensor temperature. And again, that's that T4 sensor, the SDT sensor, the source coax temperature sensor. Again, T1 is your low heat exchanger sensor. T2 is a discharge gas sensor. T3 is a desuperheater leaving water sensor. And T4 is your source heat exchanger. Now, all sensors are the same. The only thing really different on them is the length of the wire. But they're all 10K at 77 degrees. And we do have a chart in the manual that'll give you some resistance readings based on temperature so that you can read that sensor and ohm it out and see what temperature it's reading. I will say we don't have a lot of problems with these sensors reading a wrong temperature. They'll normally either they'll be open or shorted is how that they normally fail. They don't normally read a wrong temperature. So when using temperature sensors, it's important to have the proper dip switch settings, that red box right there in the middle. So again, if we're looking at a source coax freeze protection fault, so the source coax is in the lower right-hand corner of this picture. If the flow switch, FSW switch, is in the on position, then we're monitoring a thermistor that's located on the source coax refrigerant line, not even the water line. It's looking at refrigerant temperature. One thing I want to note real quick, if you get a source coax freeze protection fault, it could be a refrigerant issue, low on refrigerant, or an expansion valve stuck closed, or it could be a water flow problem because we're looking at refrigerant temperature. If you don't have proper water flow, it's going to drive our suction down and give us low pressure. So that's what that T4 is looking at. It's looking at refrigerant temperature. If we have a dip switch or a flow fault and we have a flow switch installed, the paddle switch, and it's coming over here to the terminals, then it would only, well, you could have a refrigerant issue, but it's normally going to be an actual water flow fault. The older units had a paddle switch, and the pressure of the water flowing across it closes that switch. So just depending on how you have the dip switch set up, is going to decide if you're monitoring T4 or you're monitoring the actual flow switch terminals. A low coax or a coil freeze fault will look at your T1 sensor, and that's located on the line in between your load heat exchanger and your expansion device. So if it sees that low coil is below 30 degrees for more than 30 seconds, it'll open up that switch. A lot of times that's caused by a airflow issue, or if it's a water-to-water unit, a load water flow problem. Discharge gas sensor, that's a T2 sensor, and it's located on the discharge gas line of the compressor. It will lock it out if it's higher than 220 degrees for more than 30 seconds. Again, source coax water flow or freeze fault, again, that's that T4 sensor. And depending on the dip switch is going to decide whether you're looking at the sensor or the flow switch. Sensor issues, we do have quite a few different faults, and I'm not going to get too in depth with the faults. I don't expect you to remember all the faults, but they are listed in the manual. So like a low coil temperature sensor fault would be a T1 fault, and that would be a code 14 in the manual or on the diagnostic chart. You know, these are just some of the sensor issues. Discharge gas temperature sensor issues, code 15. So it'll tell you if the sensors are having issues as well as a discharge fault. So we list quite a few faults, and there could be, again, numerous lights lit up on the unit. Now, we do have the sensor T2 and T3 that will monitor discharge gas and also superheater water temperatures. And so there's a sensor there for that, and it'll give you a code 16 if there's a sensor fault for that. Again, we talked about the T4 sensor and its uses there. If you have it in test mode and you get a fault, it'll tell you if the sensors are swapped. If for some reason the factory plugged them into the wrong, or if you're replacing sensors and you put them in the wrong position. If it's in test mode, it'll tell you if they're swapped. Here is the chart in the manual that'll tell you what the fault means, and it'll kind of give you some notes on what what the fault may be. You know, let's say 14 is a sensor T1 bad, and you're in a lockout. So you're going to have a green high pressure light is flashing, the condensate overflow, the fourth light down is on. That will give you a note of note number 5, which it tells you this fault indicates a bad sensor, open, shorted, disconnected, or invalid value. So it'll kind of give you an idea of what you should be looking at. And it'll tell you, what your T1 to your T4 sensors are. So in case you forget what those sensors are, you don't have to trace them out. It'll kind of tell you. So, we're monitoring the superheater temperature now. So we like to call it a smarter desuperheater. Before, as long as the desuperheater water temperature was below 130 degrees, it would run your desuperheater pump, regardless of anything else. With things getting more efficient, we're now going to monitor, if you look in the upper right, you see those 2 circles, your T2 and your T3 sensor. So basically, your T2 sensor is your discharge gas temperature, and your T3 sensor is your domestic hot water leaving water temperature. So now we're looking at those two and comparing them. If T2, your discharge gas, is less than your T3 water temperature, it looks at that and says, well, I can't really get any heat from the refrigerant circuit and put into the water, so I'm not going to run the pump and waste pumping watts. So here in this example, it would say I can't get any heat from that 100-degree discharge gas, so I'm going to leave the pump off. So here we've got 150-degree discharge gas, 132-degree entering or domestic hot water temperature. So now it says, okay, T2 is greater than T3. So I can get some, I can put some heat into that water. I can steal a little bit of it and put it into that water. But we do have a limit of 130 degrees. So it also looks at that upper limit and says, I'm already at 130 degrees, so I'm not going to start the pump. Now we've got 125-degree discharge gas, 115-degree water. It says my discharge gas is greater than my water temperature. So now I would go ahead and turn on the pump and go ahead and run our de-superheater circuit until either T2 is less than T3 or T3 has reached the 130-degree limit. So now we just don't run the de-superheater pump all willy-nilly. We actually compare numbers and say, okay, yeah, we'll go ahead and run the pump, or no, we don't. It just saves us a little bit of pumping power and wasted energy. A unit that does not have a de-superheater will not come with that T3 sensor. We're just not going to ship it. It will have a T2 because we still do want to look at discharge gas temperature. So with that, that's the lockout board overview, a little bit of the faults and things. So if you have any questions, definitely reach out. Again, check out the IOM when you're on site, and then give us a call with any questions on the unit. And with that, thanks for joining today. I really appreciate it. If you need anything, definitely reach out either to technical services or to myself. And have a very Merry Christmas. Thanks again. Have a great day.